All right, so now is the time to have this amazing session by Arnab Chatterjee on Corda 101. So to give a brief introduction about Arnab, so Arnab is a solutions engineer at R3, an experienced professional in DLT and distributed systems. Before R3, he worked with BOSCH and NEC Corporation, seasoning his experience with Hyperledger and enterprise Ethereum technologies. From the Bureau of Indian Standards, he represents a national body to standardize blockchain at the ISO TC 307 committees. Really looking forward to your talk today, Arnav. Over to you.
Thanks a lot, Anjali, for the amazing introduction. So, all right, so I think we have a very enthusiastic tech community already waiting to understand what Corda is and what DLT is. So without further ado, let me just share my screen and get started. All right. Can you confirm if you can see my screen?
Yes, I can.
All right, so welcome to Corda 101. My name is Arnab and I'm a solutions engineer at R3. And the department where I belong from is called Professional Services. So R3 is responsible and R3 is the creator of the distributed ledger platform called Corda, as well as the confidential computing platform called Conclave. Although Conclave is another product, but we will mostly be discussing Corda and distributed ledger technology today. So before getting started, a little bit about me, in addition to what Anjali already mentioned. One of the things that I have experienced over my career is, across multiple different domains, across multiple different fields, is what DLT looks like in different technologies. And one of the things that I can say with Corda for sure is that it's built for the enterprise grade applications. It's not something that you can compare directly with Bitcoin, although there are inspirations from Bitcoin that has flown into Corda, and also you cannot compare it with Ethereum, right? Or major other public blockchain platforms. But Corda is mostly, enterprise grade, and it's suited for enterprise distributed applications. So where do we exactly stand within the context of R3 and what R3 actually does? So R3 is all about, I said, the products that we roll out, Corda and Conclave, and we maintain we develop and maintain these enterprise grade applications. Where I come from is the professional services team, and we basically help teams go live with enterprise grade solutions. So for example, if you in your enterprise or in your financial institution, let's say bank or insurance companies or whatever it might be, is looking at a financial use case or finance driven use case, you come to us and we help you take your idea into fruition, right? So we take your idea, we design it, we develop it, we deploy it, and we also help you, maintain it once it's live, right? And to the best of my knowledge, right, like Corda is perhaps one of the leading platforms out there where most enterprise grade, blockchain applications are running as on date. So you can really see it's really, production grade. It has all that production grade toughness and the resilience to process transactions and to process production grade applications in the real world. And the last pillar, which is last but not the least per se, is our strong ecosystem and our strong market presence out there. So you see that a lot of financial institutions, a lot of banks, a lot of CBDCs are basically rolling out on Corda. And if you have a look at the Google Trends as on date, you can see the sheer amount of production grade financial use cases that are there. So it's obviously beneficial if you roll out your systems on Corda, that you get a wide range of network to interact with. So it gives you this strong market presence to build your applications on. Right. So getting started with what is Corda, having spoken so much about Corda, like let's understand a little bit in depth, in technical depth. So in the agenda, we have an overview of what Corda is and why Corda is different from other ledger platforms, right? Like Bitcoin or Ethereum. And then we'll be seeing some of the key concepts that makes Corda tick, right? So what are the fundamentals that we need to know, and how those fundamentals are different with in contrast to other ledger platforms. And finally, we got a little surprise for you in terms of how you can quickly get started, as well as have some goodies in store within the Corda community. So we'll be talking more about that in later in the presentation. So let's look at why Corda was built in the first place. So this is basically the mission objective, right? Like the values that we stand for. So the developers of Corda, the architects of Corda stand for these values, right? The idea is to have the architecture for an open enterprise grade shared platform, which can be used for immutable recording of financial events and execution of logic. So what do we mean by that? So first is open, right? So we need to have transparency between what we use and what we think, will support our vision or our use case. So there has to be our platform has to be open source so that we can clearly see what's on the other side running on a server or on a machine. So that's first. The second is enterprise grade. So unlike public blockchains like Bitcoin or Ethereum, it has to be ready and toughened for the enterprise. That means it has to cater for high scalability, high performance, and it has to really stand the sands of time. That means it should be built on tried and tested technologies. And the third one is basically a shared platform for immutable recording of events, right? So the platform has to be shared. That means it has to be logically connecting multiple parties across geographical boundaries, across enterprise boundaries. And the platform should be able to record certain events, certain facts on the ledger in an immutable, non-repudiable way. That means once I've written to that ledger, there's no way for me to go back, and there has to be a indelible consensus amongst the participants who are recording the facts on the ledger. So these are the core values that we stand for. And unlike most blockchain platforms out there, who are very enthusiastic about starting a blockchain use case and really looking forward to getting their hands dirty on a new technology, the mission objective for Corda is quite different. That is, we really look at the requirements first rather than the technology first. So we really boil our ideas down into the basic requirements, and then we build on top. So there are these couple of fundamental requirements that the banks, the financial institutions have given to us, and based on that, Corda was built. So what is the problem that we're trying to solve? Let's look at that in a little bit detail. So assume that there are two parties out there. One is a buyer and another is a bank. So the buyer wants to buy something or wants to approach the bank for some funding, right? For some loan requests. So before the advent of the internet, the way the communication used to work is that the buyer and the bank would sit in their silos, would sit in their respective institutional boundaries, and then want to perform an action. And the last leg, that is actually the communication, used to happen either through a mail or through some document exchange physically until internet arrived, right? So you can really see the flow of actions basically starting from one party deciding to act and then process it and then communicate it to the other party, and the other party is basically taking that forward from there, right? So there's no concept of a shared action boundary. There's no concept of a shared perception of what the fact is there. So what I record in my books is probably not what you record in your books, right? So that's the difference. Now, with the advent of the internet, the things changed a bit. Like there's no more, people running around with files, so you can directly send information across the internet. So you directly make use of the wire and basically send that, hey, I want to purchase something, so give me $1,000 worth of loan, and this information quickly gets transmitted to the bank, and the bank starts acting on it. But then again, the information flow is actually what's happening over the wire. So the concept of what I perceive, what I see as a fact, and what bank sees as a fact is still different, because I might be using one type of system, the bank might be using a different type of system, right? So there's no concept of a shared perception or a shared truth over here. Now, with the advent of shared ledgers or distributed ledgers, what really started happening is that the application layer, the application started getting shared across organizational boundaries. So you really have one bank or one buyer really sharing applications with another bank. So you really can't have this even as on date, although as we are speaking, there are certain real life examples of distributed ledger applications, but still the majority of the banking landscape looks like that one bank has its own application, one core banking application, another bank has their own core banking application. So there's no there's no perception of the shared truth yet. So this is what's Corda is fundamentally trying to shift, right? So it's trying to build this common bridge that acts on these three layers. What's the shared truth? What's the shared perception, and what's the shared logic based on what we are operating on, and finally the shared communication as in the internet itself, right? So it's adding these last two layers, as you can see, the concept of the shared logic and the shared truth. So fundamentally, right, like every application, every technology that's out there is designed to solve one problem, and one problem very well, right? Like you cannot have a cake and eat it at your same time, eat that at the same time, right? So there will be certain trade-offs, and what Corda tries to do is tries to maintain the optimal balance between the trade-offs in terms of the problem is trying to solve and the domain it is intended to operate in. So you will see that there are certain pros and cons of using Corda, but Corda really fits well. That's why I say it. Corda really fits well in one market and one type of space, and that is the enterprise distributed ledger application space, not in the public space, right? Not like Bitcoin, not like Ethereum. You cannot compare that with Corda. And if you are a tech enthusiast, and if you have been following technology, you know, like there are no silver bullets out there, right? Like it's all fundamentally technology and what the technology is ultimately solving at the end of the day. So with this said, right, let's look at what are the different trade-offs that we have when we try to use Corda. So as I said at the very beginning, Corda is permission, unlike permissionless platforms like Bitcoin or Ethereum. Corda is not actually a blockchain because there are no blocks in Corda. It's more of a distributed ledger technology. Another very important and interesting fact is that unlike Bitcoin or Ethereum, which are very, very public and open in terms of the information that's shared across participants, Corda is very point to point. It's very privacy focused. So you do not have the facts that you want to share with, let's say, bank A, going somewhere into bank C or bank D, right, who are on the same network. So it's very privacy oriented. So you just share the messages, you just share the facts, the party or the participant you want to interact with or deal with. There's no concept of like public broadcast, like Alice sent 1 Bitcoin to Bob, and that fact is like disseminated to everyone out there in the network. But that's not the case for Corda. Corda just limits the information flow only between Alice and Bob. Another trade-off that we see is that Corda uses messaging queues, unlike other platforms like Fabric or even Ethereum, which uses like gRPC or gossip protocols, right? Corda is subtly different in that way. Messaging queues, again, tend to be a little bit more expensive in terms of the infrastructure cost that it bears on the organization, but that's, again, a trade-off that Corda consciously have taken as a design decision to boost performance. Another thing which is really sort of radically different from other platforms out there like Bitcoin is that once you have sent a Bitcoin to Bob, if you have sent that by mistake, your money is gone. I mean, you cannot take it back. So there's no law overriding, there's no law overruling your network in some way. So the code is the law in Bitcoin or Ethereum or even in Fabric. But unlike Corda, in Corda, the actual law can actually be used in what we call the smart contract. So you can have a legal binding override the actual code binding, right? So there is a specific focus on the law of the land over here. Another trade-off is that if you know a little bit about Ethereum, how Ethereum works, Ethereum uses accounts very widely. So it basically uses like one, giant book of accounts saying Alice has 10 ethers, Bob has 100 ethers, and Charlie has 300 ethers, so on and so forth. It's like a giant book of accounts. But in Corda, it's more like Bitcoin. Bitcoin deals with UTXOs. I'll not be going into detail of what UTXO is. If you're interested, I can share some material on this. And the last, and perhaps one of the most, bank-friendly or financial institution-friendly trade-off is this, that, unlike these new technologies out there, we don't use Solidity, we don't use, Golang, which are relatively newer in the market. So these are newer technologies, and there still might be, some issues somewhere. There might be some limitations, some bugs out there. So the fundamental technologies that Corda is built on is the Java virtual machine, that is the JVM, and which is really a tried and tested technology out there, and it's been there for almost like 25 plus years, and it's really tried, tested, battle tested technology, and that's what makes it really friendly to these giant institutions out there. With this in mind, Corda also provides flexibility in terms of the transaction model, the amount of information, the type of information it can store, and the contracts can be arbitrarily complex in terms of the business rules it encodes, right? So you can put in whatever contract logic you want. It also supports a variety of enterprise-grade databases like MySQL, Oracle, H2, and mostly relational databases. And it also is built on, as I was saying, trusted and battle-tested messaging broker platforms. And finally, the consensus mechanisms are also really simple out there. So we'll be talking about consensus mechanisms in the subsequent slides. Right. So I think to this point, let's quickly summarize. Corda is designed to solve a range of problems for the regulated financial markets. The design decisions made for Corda makes it suitable for mostly enterprise-grade commercial applications. Corda exists because other available platforms did not satisfy some of the stated missions out there. Like Ethereum was made to be a giant, ever-running computer. Bitcoin was made to be a global anonymous payment exchange platform, but Corda is specifically targeted at regulated financial markets. And like every other software, every other application out there, building any application requires trade-offs, and the trade-offs are clearly listed out there that we have discussed so far. So it's clearly is opinionated, but it also facilitates a lot of developer flexibility. So let's get into a little bit deeper into the Corda network and the Corda node, right? This can get a little bit complicated, so please post your questions if you think if you need any help in understanding some of these concepts here. So the Corda network is basically a network of participants with running where each participant is running one or more Corda apps. So Corda app is nothing but like your application logic, which is shared across participants. So remember the earlier slide where I said that the applications are run within the enterprise silos, but these applications initially did not share logic. But right now with Corda, they share this logic with the help of these elements called Corda apps, right? And one of the part of the Corda app is the smart contract. Corda, as I said, is permissioned, and the permission is basically controlled by a network operator called a tournament. So there's a component called the tournament, which allows people in and out of the network. People behaving badly can also be kicked out of the network. So that's the purpose of the tournament. And each identity, each participant has a unique network identity, which is uniquely identifiable in the network. So the identity is composed of a X509 name. So X509 name is nothing but a long name consisting of the organization's legal name, like for example, Acme Corporation, as well as the location where it belongs. Maybe it belongs in Singapore, it's registered in Singapore, and its country as well. So in this case, Singapore is also the country. So with this, trio, you can uniquely identify, yeah, this is the particular organization, this is the particular enterprise I'm talking to. So I really know that this is registered in these premises in this jurisdiction. So I can actually have the law of the land dictate the terms should something go wrong. Each network is basically, scanned or maintained by a network map. So a network map is something like a phone directory, right? So you look up an organization name in the network map, and it gives you all these details, like what's the public IP address, what is the public key of that particular organization, right? So you need that to communicate between these organizations. And finally, all communication between these nodes are happening in an encrypted manner with a protocol called AMQP. So it's for those who have a little bit knowledge around messaging queues. AMQP is the data standard which is used in technologies like RabbitMQ or Apache ActiveMQ. So Apache ActiveMQ or Apache Artemis is actually what's used in Corda. So with this view in mind, let's again dive deeper into what an actual Corda node looks like, right? Like if I were a participant like Acme International, what would I be actually running out there, right? Like what would be there in my server? So let's have a look at that. So the Corda node is basically, as I said, a Java virtual machine, which is running the Corda software. And the Corda software has various components. I won't be going into very detail into each of these, but notice that the Corda components has messaging components to it that allows people to talk to each other. It has key management to store private keys securely. It has identity services to, as I said, request for permission to join the network, request for other parties' identities so that a transaction could be completed. And finally, there's this thing called the vault service, which actually stores all your transactions. So when you transact with Bob, as I said, the facts are only shared between you and Bob. So those facts are basically stored within the vault. So it's basically a database at the end of the day, right? So that's pretty much it. And to interact, you basically have two layers out there. One is the RPC layer. RPC layer is used for communicating with other applications within the enterprise. So for example, if you have a banking application, a core banking application, or maybe a trade finance application already running in your enterprise, but you want to enable it, you want to further, empower it to have this distributed nature so that your application can actually talk to other applications across enterprise boundaries. That is where you would use a Corda RPC layer to sort of glue your application and Corda together. So with your application in one side and Corda on the other, you basically are now empowered to do transactions within your enterprise boundary as well as across your enterprise boundary. And on the other hand, as I said, like the Corda node is basically allowing you communication with other Corda nodes across other enterprises. That's where the network layer will actually come in, and it'll do all the network translation of running the Corda apps, running certain communication logic, and doing a bunch of different stuff, right? Which we will see in the subsequent slides. All right, so let's now dive into a very interesting concept called the node tree and consensus. So till now, you have understood that a Corda node is able to interact with other nodes through this network layer, and it's able to share and record facts, only within the stipulated parties, right? Only across stipulated parties. But what happens when a party decides to, go bad? When some transaction goes awry? What happens then? So some party can, let's say, Bob can decide to be malicious, and Bob can decide to double spend some tokens that maybe some bank has issued to him. So that's where the node tree comes in. So the node tree is basically overseer in the network, right? So the node tree basically performs what we call as the consensus. Right. So the consensus is divided into two different types of consensus. One is validity consensus, another is uniqueness consensus. So the first thing that I talked about, like, let's say Bob decides to go bad and decides to, spend the tokens twice, right? Like, let's say it wants to buy soft drinks and wants to buy, let's say, burgers. What happens then? So the node tree is basically, as I said, the overseer of the network. So if you run a node tree in validity mode, like if you run the node tree as a validating node tree, what you can do is essentially check if a transaction is done with the right intent. So if the transaction is valid as per the smart contract rules, if the transaction is not being is not spending a fact twice. So what I mean by that, spending a fact twice is that Alice, being a bank, issuing some tokens to Bob is a fact. And Bob using that token to buy something is another fact. So how do I ensure that Bob does not, spend that fact twice, spend those tokens twice, is what will be checked by the consensus mechanism. So there are, as I said, there are two types of consensus, validity and uniqueness consensus. So validity consensus is checking the actual rules of the transaction, right? Like what is actually coded in the smart contracts line by line. And the other type of consensus that's out there is called uniqueness consensus. So this is basically rather checking the transactions more at a broader level, like it's checking that a fact is not spent more than once. So it's with this mode, you're not really prying into the contents of the transaction. You might think that, hey, if I share my transaction with this guy called Notary, then he might look into my transaction, right? He for the purpose of validating it, he might pry into my transaction. So for that not to happen, you can run a bare bones uniqueness consensus. So Corda has mechanisms to say that the notary doesn't see anything, the notary is blind, but the notary can still verify that this particular fact with some particular identifier is not spent more than once, right? So that is the purpose of consensus over here. And it's a very, very important piece in the puzzle, because once you start doing transactions across multiple parties, some guy out there needs to oversee all those transactions in terms of uniqueness and validity. And this guy called the notary does that job. So as I said, there are two types of notaries. One is the validating notary who actually, pries into a transaction and checks line by line. Yeah, this is the logic that's being executed in the smart contract and so on and so forth. And there's this other kind of notary which says that, yeah, I don't care what's there in the transaction. I just check that transaction identifiers and I check that the transaction is not being used more than once to do some other transaction. So the purpose of the notary is basically to prevent double spends via this mechanism called uniqueness consensus. And a notary can be a single node like every other Corda node, or it can be a pool of nodes. Now, knowing that this notary entity is a very important entity overseeing all the transaction, it cannot depend on a single node for its reliability. So that node can crash at any point of time. So the idea is that you run a pool of these nodes to ensure that should one of these nodes fail or one or more of these nodes fail at any point of time, you have other nodes backing up for this operation. That's basically the notary pool. Yeah, right. So now let's connect the dots a little bit more, right? Like I've talked about facts, I've talked about transactions, and I've talked about this broad concept about notaries. Now, what is going through the wire? What is it that I actually need to worry about as a developer or as a Corda developer, right? As a Corda maintainer? And there are these three fundamentals of Corda that we say that should concern a Corda developer. One is the state, another is the contract, and the third one is flow. So let us understand these three concepts a little bit more in detail. So what is a state? So a state is basically a storehouse of information. So you can consider this as a piece of paper. And this piece of paper is digital in nature, right? So you can write certain facts to this piece of paper, and you can send this piece of paper containing this information to other parties. Now, other parties might receive it. Upon receiving it, like since it's digital, right? Like you basically can make a copy and send it to every other participant in the network. The other participants can store it, can update that particular fact that's written, and also can consume it. So what do I mean by the last two, get updated and consume it? So when I say update it, let's say Alice had 10 coins or 10 tokens issued by some bank. This is a fact. This is an information that's stored in a state. So with this information, Alice now can spend, like, let's say one of these coins or one of these tokens to buy, let's say, soft drinks, one of these coins to buy certain, let's say, groceries, another of these coins to buy something else. So it's basically updating this state, this information, saying that, okay, I had 10 tokens at the beginning. Now I have 9, now I have 8, now I have 7. Now this is the information that's getting updated within the state. Now, once the state is, let's say, consumed completely, let's say all these 10 tokens are consumed, the token is gone. You cannot use it anymore. Now, how can you ensure that this token is gone? And how can you ensure that once that value was 8, it only has to come down to 7 and never back to 9, right? Unless the bank gives it more tokens. So this is basically what's enforced by the transaction. So the states are basically the physical, the digital manifestations of facts in time. So initially, let's say Alice had 10 tokens, and then it had 9 tokens, then it had 7 tokens, and so on and so forth. The manifestation will take certain paths, right? Like it'll start with 10, then 9, then 8, and so on and so forth. So there must be certain rules that govern that it has to only go down unless some issuer is sending in more tokens from the other end. So what is that thing that ensures this? That's basically your contract. So contract has multiple rules. The rules basically define that tokens once spent cannot be spent once more, or tokens can only be spent in denominations of 1, 2, 5, and 10. And there could be a bunch of different rules what you can code in the smart contract, right? So the tokens basically are states, and the states store facts, and the evolution of these facts is governed by what we call as a contract. Now, we have a very brief understanding of what a state is and what the contract is. Now, what on earth is this flows? You might ask, like, okay, I get the concept of states and contracts. Now, what's flows? Now, look at the diagram below. I think I might have a bigger diagram out here. Yeah, this is a contract. Yeah, let me come to flows and then get back to the previous diagram once again. So what you see here is that there are two parties, party A and party B, which are designated by node A and node B. They basically exchange messages with each other in this particular swim lane diagram. So node A says that I have certain fact. I want to update this fact. Like this updating of this fact can be as simple as I want to change my token balance from 10 to 9, and I want to buy something else, right? Like these are two facts. So this is the update I want to propose. I check this update against the smart contract that I've been provided with, right? So I check it against, I run it against the smart contract and see that, yes, this is a valid update. The smart contract approves it. And after that, I sign it. That means I say that I, node A, sign this, and by signing, I say that I cannot go back on the on what I said as per this update at a later point in time. So I cannot repudiate. So by signing, this concept of non-repudiation is enforced. And once I do this, I send this information to node B. Node B also does this checking, saying that, okay, you think you have updated it, you think you have updated it, and you think you have conformed to the rules that's there in the smart contract, but let me verify it on my end as well. So I run the smart contract, I sign it, I say that, hey, everything looks hunky-dory. I sign this transaction and I send it back to node A. Node A finally says that, okay, node B agrees to it. I got node B's consent to it. I can then finally send it to the notary for signing it, and then by signing it, I say that, yeah, notary has overseen the transaction, has signed it, has approved it, and now this transaction is there in both our vaults, in both our ledgers, in both our databases. So this is a very high-level overview of how the transaction will work. And who facilitates this? There's this underlying network layer. There's this underlying communication layer called the flow that's called flows that facilitates all of this. So going back, right? So as I said, contracts are basically allowing you to evolve a certain fact, a certain state, and you have in a transaction, you basically have some input states, a fact as an input, and you propose an update as an output state, and that proposal from an input state to an output state is basically what the transaction is. And the transaction then is sent to the contract for verification and validation. And once that's passed, as you've seen in the next slide, that it goes to the notary, it goes to the other parties, then it goes to the notary to finalize and get permanently recorded on the ledger. So yeah, I think I have covered quite a bit of what flows and contracts are, everything at least you need to know for the 101 section. Right. So to sum it up, right, what does a flow basically give you? The flow gives you these very fundamental mechanisms to construct a transaction, that is to build it, to verify a transaction against a smart contract, to sign it, to say that, yeah, I as a party, if I'm proposing it, I say that I sign it and I cannot go back on my word at a later date in time. And if I'm not proposing the update, if I am being asked for my approval, if I'm being asked for an endorsement, then I sign it saying that, yeah, I also have verified what the other party has proposed, and then I agree to it. So hence I sign it, and then I send it across to other party in the network. right? So this is what, in a very very concise manner, what the flows gives you. But there's a whole lot more. Of course, this is like touching the iceberg. There's a whole lot more that I encourage you to go into the docs and have a look at that. Right. So with this, I think I come to a logical conclusion of what Corda 101, is. And in the next section, I'm going to give you a very brief overview of what's in store for you if you decide to tread the path of Corda development and use Corda, right? So over the time, as you've already seen, and perhaps one of the reasons why you have decided to join this webinar in the first place is that you find distributed ledgers, you find blockchain very interesting and intriguing. And with that in mind, you see there's a potential for you to grow your career over here, right? So what are the opportunities that are stored in store for you? So over the time, blockchain has seen huge traction across multiple different fields, right? DLT has seen traction across multiple different fields, but the field perhaps, or the domain perhaps, that has seen the most traction is the financial services and the regulated markets over the years. So you can see that, adoption-wise, financial services are probably leading in this space. Also, in terms of the venture capitalist investment trends out there, perhaps like blockchain has seen again a lot of traction over there as well. Like a lot of tech companies, have got a large investments to pursue their paths, to pursue the technology choices in blockchain and DLT. So of course you see the graph has fallen slightly a bit with COVID, I surmise, but still there's huge traction out there. And in terms of job market statistics, of course, I'm showing this for India, but I'm pretty sure the job market statistics for other countries are equally riveting as well. Is that you see that the market share of the developers or the skill sets people want in terms of technologies is hugely dominated by Corda and Hyperledger, right? So Corda again has huge traction in the financial and regulated markets in terms of the job offerings it gives, right? So how can I get started, right? Like I'm a complete newcomer. I find this really, really interesting. I find this really intriguing. How can I get started? So there are a couple of great resources out there, but to really make a point, what I would encourage is that, get certified. There are good certifications out there. So if you are a developer, you want to, pursue a path in development and architecture, then there's this Corda developer certification. If you want to, lead the business front of it, the business analysts is part of it, then there's the Corda for business certification. And then there's this third certification, which is Conclave developer certification. Conclave, as I said, is another sister product of Corda, which specializes in confidential computing. So perhaps I'd be happy to give a 101 on Conclave as well in one of the future webinars. But know that Conclave is equally complementing and to the distributed application space, and it really pays off to be a Conclave developer as well. So where can I get certified? There's this website called hearttreecertification.com where you can go ahead and register yourself. But there's more, and there's the surprise for you. So if you go ahead and get registered at developer.archery.com, I'll be sharing all these slides with you. I think Anjali will be facilitating that. But if you go ahead and register on developer.archery.com, you get free certification codes for all of these 3 certifications, and this is for limited time. And my development community at Archie has pushed me to spread this word to as many enthusiasts as possible, so that everyone can make great use of this opportunity. And I would encourage you to do that. There's this really great website out there where you can register. And developer.r3 is a portal focused for budding developers who are getting started with Corda and Conclave, for all types of tech help, for all types of community discussion, to stay updated on what are the releases, to get notified of new features and all of that. It's all there in developer.r3.com. Community.r3.com is more of a forum kind per se, where you can interact with fellow developers out there. So yeah, that's pretty much it. I think that's the end of the presentation. I think this was really quick, and I hope it was useful. It gave you a little bit of insight on what Corda is and what are the basic fundamentals of Corda and how it solves certain problems. Yeah, happy to take any questions.
Thanks, Arnab. I think there's one question in the Q&A from Charu. So she is asking, in Corda, who owns the decision making of valid transactions?
Yeah, I think that's a really great question. So when someone makes a transaction, it's not, first of all, it doesn't happen unilaterally, right? So you have to understand that when we talk about distributed application or decentralized applications, the logic that gets executed, the smart contract logic, to be very specific, is something that is agreed and executed by all relevant participants in the network, or in the transaction, to be more specific, right? Not in the network. That's a mistake. So all participants who are logically involved in that transaction basically sign and endorse, saying that yes, I have got the fact that someone is proposing a transaction that's saying that it is, the transaction has to start from state A and has to go to state B, and whatever that state A to B might entail, right? But the very fact that it starts with state A and goes to state B is a valid fact, and is marked by the smart contract rules as valid, is first, the first thing to make a transaction valid. And the second thing is basically getting the signatures of all the relevant participants involved, right? So with these two things involved, with these two things totally encompassed, you basically make a valid transaction. And the final piece of the puzzle is that you notarize it, right? You say that I have proposed this transaction, and the notary has seen it to be unique and valid. So that's the third piece of the puzzle that collectively makes a transaction valid. I hope that answers your question.
Okay, she has just replied in the chat saying thank you. That's great. Any other question? We still have some time. So if you have any other question, please feel free to add it in the Q&A box. Okay, I think if there are no other questions, then we can just wind up today's session. Arnab, thank you so much for your time and for going through all of these details. It was really beneficial for all the members. And the recording will also be available in YouTube in a few days. And we'll be sharing it with other attendees who could not attend today's session. So thank you so much, Arnab.
Thank you. It's a pleasure to be here.
That's great. Thank you to all the attendees as well. And take care and stay safe, everybody.
Bye-bye. Take care.